Hello, this is Charlene. We're going to be talking about finite versus infinite sets. The first thing that they tell us is about a finite set. A finite set is set A is a finite set if the cardinality of set A is equal to 0. That is, A is the empty set, or the cardinality of set A is a natural number. So they are telling us that for a finite set, we're either going to have a cardinality of 0, which means it has 0 elements, or we're going to have a cardinality that is some natural number, which means it's going to be a counting number. It will start with number 1, but it will definitely be in the natural number category. The second thing it's telling us about is the infinite sets. It says that an infinite set is a set whose cardinality is not 0 or not a natural number. That is what we call an infinite set. So essentially, the cardinality of an infinite set means it will not be 0 and it will not be a natural number. So we'll talk in a few minutes after we talk a little bit more about finite about what that means if it is the cardinality is not 0 and the cardinality is not a natural number. Okay, but let's go back to our finite set. The word finite, and other words that are associated with the word finite are final. If we have a finite number of things, that means we have a final number of things. We could say, how many rounds do we play in order to get to the championship? Well, we might get to round 3 or round 4, but then that would be the final round, whatever we get to. And so 4, if they get to round 4, then that would be the final or finite number of rounds that we played in. We get to the finish, we get to the end, or we have a definite number. So those are all like different words that kind of help us understand what the word finite means. It means there's a final number, there's a finish line, there's an end place, there's a definite number if it's finite. Let's talk about finite sets first. Again, the finite set has a cardinality that can only be 0 or a natural number. And just to remind you, in case you've forgotten from previous videos, cardinality means the number of unique elements. That means that we count all the elements, but we do not count duplicate elements. So that's what the unique part is, that we do not count duplicates. If it appears twice, we do not count it twice. Okay, but let's go over here to a finite set that has a cardinality of 0. Here's an example of one of those. A set A is the set of names of months that begins with the letter P. Okay, so let's go ahead and put our little brackets up here. What month begins with the letter P? Are there any months that begin with the letter P? No, there are no months that begin with the letter P. So it is literally the empty set because there are 0 elements. That means the cardinality of the set would be 0 because there are no elements. And of course, you can also denote that by the empty set with the 2 brackets with nothing in it, or you can use the null symbol. This is the null symbol, which means there are 0 elements in it. And then we also have the idea of a finite set, which has a cardinality that is equal to some natural number. So let's look at this one right here. We've got B is equal to soccer, basketball, football, baseball, and volleyball. So what would be the cardinality of set B? Well, unique elements. I've got 1, 2, 3, 4, and 5. So that means the cardinality of set B would be equal to 5. Now, is 5 a natural number? Yes, it is. It's a counting number. Natural numbers are counting numbers. So this is the example of a set with a cardinality of 0 because there are no elements in that set. And this is an example of a set that has a natural number cardinality. It has 5 elements, 0 elements or 5 elements. Those are the two options for finite sets. Now let's talk about the infinite sets. An infinite set is a set whose cardinality is not zero or not a natural number. So essentially, if it's not a zero and if it's not a natural number, the only thing that is left is infinity. Infinity. Because it cannot be a negative number, cannot be zero, but our list of numbers, our set of numbers could go on forever. And if there's not a final number, there's not a definite number, an end to the numbers, then it will be infinity. Okay, so let's look at this example here. We've got set C is a set of all positive even numbers. Okay, so again, it is not zero, but there are going to be some numbers in our set. What kind of numbers are going to be in our set? Well, we have been told that they are all positive even numbers. So what is the first even number? 2. 2 is the first even number. The next one is a 4. 2, 4, 6. And it says all of them. So that means it's going to go 8, 10, 12, and it's going to keep going on. It doesn't have an end. So these ellipses right here, dot, 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 that's an ellipsis. Let's change the color there. Green means forever. It goes on forever. The list of all the positive even numbers is never ending. Now, do you and I know what those biggest numbers are? No, it'd be kind of crazy to come up with an idea. But anyway, it's going to go on forever. So dot, 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 the ellipsis means it goes on forever. And so that means that this set, set C, is an infinite set. It goes on forever. We do not know where the even positive numbers end. It is infinite. Okay, so our next set says D, the set D is dot, 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 which are ellipsis, -5, -4, -3, -2, and -1. Well, since -1 is at the end, that is actually the final number. So it ends on that, on the positive side, the right side, if you're looking at a number line, it would stop at the -1. It would include the -1. However, on the front end, going this direction, it is going to go on forever in a negative direction. A negative direction. That is not how you spell negative. So the negative direction, the dot, 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 the ellipsis, means it's going to go on forever. If we were looking at it in terms of a number line, we would have, that -5 and -4, -3, all the way up to the -1. -1 is in the set, so we would have a closed circle, and then it would go this direction, but the dot, dot, dot means we do not know where it ends. So that means that it would go on forever and ever. So you would put an arrow there, and that would indicate that it's going in a negative direction, and we do not have an end. So if we do not have an end, even on the negative side, this set D is going to be an infinite set. Now they would like for us to determine whether the given sets are finite or infinite. So the first set they've given us is n is equal to 1, 2, 3, 4, 5, 6, dot, dot, dot. What does that dot, dot, dot mean? It means that's the ellipsis, and it's telling us that it is going on forever in the positive direction. So it's a positive direction, but we do not know where it ends. We do not know. It's like, that's a mystery. So therefore, if we do not know what the final number is, we do not have a definite number, this means that set n is infinite. It is an infinite set. Our next problem says that x such that x is an element of the natural numbers and x is greater than or equal to 50. So this first part right here, x as an element of the natural numbers, means that it is limited to the counting numbers. So that means we would have to start with the number 1. That's where we always start counting. So it's going to be limited to the counting numbers. And then it also says that our numbers are greater than or equal to 50. So it's in the counting numbers, and it's going to be greater than 50. So if we think about that, like on a number line, we could write it like this. We've got the 50, and again, it says it's greater than or equal to. So if it's equal to, it's actually going to be colored in. It's going to be a solid circle on 50, and then it says greater than, so it means it's going to go this way. Going to go this way. So that means it's going to be all of these numbers. And does it tell us where our numbers end? Well, no, it does not. That means that we would have an arrow, and that means it would go on. Oops, doing kind of weird things there. It is going on forever. So another way to write that would be with the braces. And we could start with the 50 because 50 is included. It is equal to the 50. So 50 and 51 and 52. And then we could go ahead and just put dot, dot, dot to represent the fact that this is going on forever and we do not know where it is going to end. So again, the ellipsis always means it's infinite because we do not have a final number. We do not have a definite number of members of this set. So this means that our set is going to be infinite. Now they have given us a set of x such that x is an element of the natural numbers again. And again, if it's an element of the natural numbers, it means it's limited to counting numbers, which means it's going to start at 1. It's going to start at number 1. That's where we start counting. And then it also says that our x's, our numbers, are going to be less than or equal to 2 million. And again, our number line can help us kind of visualize what this means. So we have to consider the fact that it's going to start at the 1. It's going to start at the 1. So it can include the 1. So we'll put a closed circle around the 1. And then it says that it is less than or equal to the 2 million. So it says it's also less than or equal to. So equal to the 2 million, that would be a closed circle as well. And then it is less than. It means it's going to go this direction. So it's going to go all the way back down to the 1, but we are limited to the 1. So it's only going to, our set is only going to contain the numbers between the 1 and the 2 million. The 2 million. So it's going to be limited. So how many numbers are between 1 and 2 million? Well, it is 2 million. If we count from 1 to 2 million. So do we have a definite number of elements? Yes, it's limited. It does not go on forever in the negative side. It does not go on forever on the positive side. It is literally, we have 2 million numbers that will be contained in this set. So since we have a definite number, and it is a natural number, it's like we can count up to 2 million. That is a natural number. So if we have a definite number, it's a natural number, that means that our set that they have described up here is a finite set. We have a final number. We can count all the elements in this set. One final note on this particular problem, we could write 1 comma, 2 comma, and then dot, dot, dot. We could have put an ellipsis in the center in between the 1 and the 2 million. This ellipsis just indicates that we did not want to write all 2 million numbers. We do not have enough space. We do not have enough time to do that. But it does indicate that it's continuing the pattern. So like 1, 2, the dot, dot, dot means we would continue with the same pattern, 3, 4, 5, 6, 7, et cetera, et cetera, et cetera, all the way until we reach the 2 million. And then 2 million would be the final number. So the ellipsis in the center does not indicate that it's going on forever. It just means that we are skipping writing all the numbers that would be in the middle. So in the middle, ellipsis does not indicate going on forever. We definitely have a starting number. We have a final number. So we have a natural limited number of elements in this set. And when we have a limited number, a final number, that clearly indicates a finite set. Our last problem for this video says that they want us to figure out if this last set is finite or infinite, and it is the set of natural numbers less than 0. And of course, we need to remember that the natural numbers are limited to the counting numbers. So the counting numbers begin with 1 and 2 and 3, and then they go on forever in a positive direction. But they want us to look at the set of natural numbers that are less than 0. Well, are there any numbers that are on the negative side or less than 0? No, they do not exist. So that means if we had our braces up here, we would be able to put nothing, nothing in there. So it is the empty set. It's the empty set, and that is a cardinality. The cardinality of this set. Let's call this set set N. We'll call this the set N. So the cardinality of this set N is going to be equal to 0. It is 0 because there are 0 elements in here. So that is a definite number. 0 is a definite number. So it is a finite set because 0 elements or 0 members is a definite number. And so therefore we have a finite set. So I hope you enjoyed this video. Hope it helps you understand some of the processes and the thinking about finite and infinite sets. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.